everyone, welcome to Vedantu English. I'm Diksha Kaushal, your chemistry master teacher, and in this video, we are going to talk about all the physical chemistry formulas that are there and that are surely going to be asked in your JEE attempt. So let us start this video without wasting any time. So the first chapter is, that is your solution chapters, or you can also say this is also applicable in some basic concepts of chemistry, that is concentration terms. So if talking about the concentration terms here, first is mole fraction. We know that mole fraction is equals to number of moles of that component divided by the total number of moles, right? So here all the components combined mole fraction will be equals to unity, that is 1. Next formula is molarity and molality. What is molarity? Molarity is number of moles of solute divided by volume of solution in the liters, and molality is number of moles of solute, volume of weight of solvent in kilograms, right? So here the important part is that we take the volume of solution in liters, and here we take the weight of solvent in kilograms. In rest of the concentration, you will take weight in grams and volume in milliliters, right? So even if you talk about the percentage, weight by weight or weight by volume or volume by volume, so here always what you're going to do, that is going to be weight by solute by solvent. But here remember one thing, the weight will be in grams and volume will be in milliliters. That is how you're going to answer this. But if this is the same thing that is given in ppm, that is parts per million, so instead of multiplying this by 100, you have to multiply this by 10 raised to power 6. Okay, so that is about the concentration terms that will be required in your exam. Next we have is, this is the same concentration terms, right? Next is, what are the formulas that you use in some basic concepts of chemistry? So understanding some basic concepts of chemistry rather than formulas, concepts and practice is more important here, right? So do revise and practice the questions of some basic concepts of chemistry like mole concept, the questions of stoichiometry and limiting reagent. But I will tell you in a simple way what exactly you will do here. So first thing is, if you talk about strength, strength is molarity into molar mass of the solute. So if they ask you the strength and molarity, what is the difference between molarity and strength? Molarity is number of moles of solute by volume of solution in liters. Strength is weight of solute by volume of the solution in liters. That is the difference. That is why the relation between strength and molarity is strength is equals to molarity into molar mass of solute. Next is, if you talk about the molar mass and its relation with weight by weight percentage, then that is going to be a molarity into 10 into density, weight by weight percentage by molar mass of solute. But this particular formula is very important, where they usually ask that what is the relation between molality. So small m is the molality, capital M is the molarity. So m is equals to 1000 into capital M, 1000 multiplied by density minus molarity into molar mass of the solute. This formula is very, very important, right? Next is, if they ask you the relation of these, basically if you talk about the relation between moles, okay, when it comes to given mass or it comes to volume and it comes to particles here, so what you will say, that in case of mass, it is given weight by molar mass. In case of volume, it is given volume by molar volume, and molar volume usually is taken as 22.4. But what if they give you 1 bar and 273 Kelvin? So in case of 1 bar and 273 Kelvin, this is going to be 22.7. But if they take 293 Kelvin and 1 bar, then it is going to be 24.8. But at standard temperature pressure, that is 273 Kelvin and 1 atmospheric, it is going to be 22.4 liters only. What about, ma'am, if you have given particles? This is going to be given particles by Avogadro's number, that is the molar particles, that is 6.022 into 10 raised to power 23. Okay, so I'll also write it here, that is 6.022 into 10 raised to power 23 particles that can be atoms or molecules. Next beta we have, if you talk about the empirical formula and limiting reagent, two very important questions here. So for that, the formulas that you should know is molar mass is equals to 2 into vapor density. If let's say vapor density is given to you, you have to multiply it by 2 to calculate the molar mass. Next is, ma'am, how do we solve it? So how do you solve this? Maybe the percentage or the ratio will be given to you according to the atoms. So first you will calculate the moles by percentage by atomic weight. Let's say carbon percentage is given to be 20%. So that will be 20 by atomic mass of carbon is 12. So 20 by 12. Right? Then you convert it into simple whole number ratio. Simple whole number ratio will give you the empirical formula here. Right? So once you get the simple whole number ratio, you get the empirical formula. From that, you can get the empirical mass also. Now, empirical mass, molar mass is equals to N into empirical mass. Right? Molar mass, you can already either that will be given to you in the question, or you can calculate it from this formula. N will be calculated from this formula, that is molar mass by empirical mass. Then you put the value of N here. Empirical formula you have already solved. So that will be molar formula is equals to N into empirical formula. That is going to be the correct answer here. Right? Okay, rather I would write it here in the subscript. Right? Then you have the questions of limiting reagent. Limiting is one thing will be given to you in the question, that is you have 7 gram of N2, 2 gram of H2, that will be given to you in the question. Okay, maybe moles are given. So whatever is given, you have to convert it into moles. Okay, so if they have given you particles, you have to convert it into moles. If they have given you mass, you have to convert it into moles. Given by stoichiometry. Stoichiometry will be from the balanced chemical equation. Then from that you find out the smallest number, and the smallest number is going to give you the limiting reagent here. Right? Once you know the limiting reagent, directly you can say that product depends on the limiting reagent. You apply the unitary method and you will get the answer for the limiting reagent, product, everything there. Next is questions from structure of atom. So from structure of atom, what are the important formulas that you should remember? First is electromagnetic waves. That is the formula is mu into lambda is equals to c. That is the velocity of the light. That is 3 into 10 raised to 8. Right? And you should remember that the inverse of wavelength is wave number. The inverse of frequency is the time period. Right? Next is Planck's quantum theory. Remember that E is equals to h mu, where one very important thing is E is equals to h mu, hc by mu is nothing but hc by lambda. So it will become hc by wave number. Right? Now here, very important thing, what is the value of h, what is the value of hc? I have already written it here. But the conversion, for example, you write it in joules and they have asked you the options are given in electron volt. So that is the conversion. 1 electron volt is equals to 1.6 into 10 raised to power minus 19 joules. Now, ma'am, one very important thing here is that what if they have given you this electron, they have asked you things in electron volt. Directly how you can answer this. So if lambda is given in nanometers, or even if it is given in meters, convert it into nanometers, right? So 1240 divided by lambda in nanometers, or you can say 12400 by lambda in Armstrong. That is the direct relation that will really help you to solve the questions in the exam when you have less time, right? Now we know that mu frequency is additive in nature, but lambda is not additive. So that will be 1 by lambda is equals to 1 by lambda 1 plus 1 by lambda 2. That is wave number is equals to wave number of 1 plus wave number of 2. Right? Next is Bohr angular momentum. So if you talk about the Bohr model here, I'll come to the Bohr model, then I'll talk about the Bohr angular momentum. Before that, let us talk about the photoelectric effect. Right? In photoelectric effect, we know that we have an incoming incident light, that is h mu. Right? Now, the work function here is mu naught, that is given by h mu naught, right? And the energy that you are left with is kinetic energy. So we say in the form of equation is h mu equals to h mu naught plus kinetic energy, where this h mu naught is nothing but it is called the work function, right? And mu naught is the, if you talk about mu naught, that is the threshold frequency. Right, so if you want to know this, right, that is if h is greater, then electron will be ejected. If h mu is equal to h mu naught, then only ejection will happen, no kinetic energy will be there. If h mu is less than the work function, then you are not able to eject the electron here, right? Next is, what is kinetic energy? From this equation you can get, you solve this, right? You will get the formula as hc lambda naught minus lambda by lambda naught into lambda. You don't need to learn this, just remember this equation. Just remember this equation, rest of the things you don't need to learn, right? Now, kinetic energy can also be written as E into Vs, where Vs is the stopping potential, E is the charge on the electron, right? So, if those things are given, you will apply this formula. Next is Bohr model. Now, beta, Bohr model, to understand that, first is, you need to know this value of the Bohr angular momentum, that is NBR is equals to NH by 2 pi. Bohr angular momentum is integral multiple of Planck's constant, that is NH by 2 pi. Now from here, let us see, if you remember this page, you will be able to answer all the questions related to the Bohr model. That is, Rn is equals to 0.529 n square by z Armstrong. The formula of velocity in terms of n and z, the formula of time period in the formula in the way of radius and velocity. Here, you need to remember this formula and this formula. Here, if you remember just that this is directly proportional to n cube and inversely to z square, that will be beneficial. Okay. Energy, also you need to remember the formula in electron volt and as well as in the joules. Right. Now, the relation of this formula you can ignore. This you don't need to remember. But yes, this one definitely you need to remember. This one definitely, that is the relation of total energy with kinetic energy and potential energy. If I say potential energy is minus of x, then kinetic energy will be plus of x by 2 and total energy will be only half of the potential energy. Okay, so directly you can also answer this, right? Now, ionization enthalpy is inverse, is opposite of the energy, right? So, if you have negative here, here you will have positive. That's the only difference here, right? Next is, ma'am, hydrogen atom. So, basically, they ask you questions from the Rydberg equation. For that, I have written all these things here. So, this is the formula of Rydberg equation that says that 1 by lambda is equals to V bar, that is the wave number. RH is the Rydberg constant, Z square 1 by N1 square minus 1 by N2 square. Now students, very important thing to make your numericals easy, that RH is equals to 109677, that we all know. In this case, the lambda will be in centimeters. But if you need to calculate, you don't want to do the inverse of things and get into those difficult calculations. So what you have to do, put the value of 1 by RH is equals to 912. Okay, Armstrong. Then the answer will be in Armstrong. Then you can convert it in centimeter, meter, whatever you want to. Right? Okay. Now, ma'am, what is this N1, N2? You have answered Z. Z is the atomic number. That will be there in the question. Hydrogen, it is 1. Helium, it is hydrogen, helium, it is 2. Lithium, it is 3. You can answer that. But what about N1 and N2? So for N1, you need to know these lines. If either they will give you N1, N2 directly, or they will give you the hint of Lyman series, Balmer, Parston, bracket, Pfund. So corresponding to these series, N1 will be any of this. 1, 2, 3, 4, 5, Lyman, Balmer, Parston, bracket, Pfund. Right? This lies in UV, this lies in visible range. So they can also give you a hint that the one series that lies in visible range, N1 value is 2. So you have to put the value of N1, 2 in that case. So that is how they can complicate the question. Right? Now talking about N2 here. Ma'am, what about N2? For N2, what they can do, either they can give you directly first excited state, second excited state. Whenever you have excited state, you just need to add it. Right? So either they can give you third orbit, 4 orbit, so directly they can give you, right? Now, first excited state means N2 is going to be 2. Second excited state means second means it is going to be 3. Okay, N2 is going to be 3. Because for excited state, you need to add 1 into that orbit number. Directly if orbit is given, you can write 2, 3, 4. But what if they have given you first lines, alpha line, minimum energy, maximum wavelength? Then N2 will be equals to N1 plus 2. If they have given you last line, limiting line, minimum wavelength, then N2 is going to be infinity. If they have given you second line or beta line, then N2 is going to be N1 plus 2. If they have given you third line or gamma line, then N2 is going to be N1 plus 3. Okay, according to that, you will answer N1 and N2. Now here, what you need to remember, that as you go down here, the energies is, as N is increasing, energy is increasing. But the delta E is decreasing because the gap you can see that is decreasing. Here you have maximum gap, then it is decreasing as you go to infinite orbits here, right? Next we have de Broglie wavelength. For de Broglie wavelength, what is important? Lambda is equals to h by p. P is nothing but mv. You can write it in this form and this form as well, that you have done already, right? So for nth orbital, beta, you can also form that from nth orbital. We know that 2 pi r is the circumference. So if you see this thing here, if you talk about de Broglie wavelength, talk about the dual nature. Dual nature means for wavelength it will be n into lambda. For particle nature, it will be circumference, that is 2 pi r. So from that we can see Bohr model, Bohr angular momentum is also valid here, right? Then Hensburg uncertainty principle, what we have here is this uncertainty in position and momentum, or uncertainty in position and velocity, is always greater than equals to h by 2 pi. That means you can't predict both of the position and velocity at the same positions, at the same point simultaneously. Next is for quantum numbers. So we have 4 quantum numbers in which spin quantum number is not solution of Schrödinger wave equation. Okay? Now, talking about the formulas here, the formulas are: principal quantum number is 1 to infinity, azimuthal quantum number is 0 to n minus 1, magnetic quantum number is minus L to plus L, and spin is going to be either plus half or minus half. If they ask you the number of subshells, it is n, number of orbitals is n square. Now in one orbital you have 2 electrons. So number of electrons in the subshell is going to, in the shell is going to be 2n square. Number of orbitals in the subshell is going to be 2l plus 1. Number of electrons in the subshell is going to be 2 into 2l plus 1, that is 4l plus 2. These formulas are very, very important. These are also very important because right now they are asking you questions based on the quantum numbers. Okay. Angular orbital momentum, that is given to you. Angular spin momentum directly given to you. Right? Okay. Next is beta Aufbau principle. For this also they ask you questions. That is when you talk about n plus L rule. Okay. So directly what you can see, n plus L increases, energy will increase. Right? If n plus L is same, then as n increases, energy will increase. From this also they ask you the questions. Next we have equilibrium. So for equilibrium, what all you need to remember is law of mass section. Okay. Law of mass section, let us see that here. So if you see this law, Kc is equals to Cc, that is, see, whenever you have equilibrium constant, always, whether you talk about concentration, pressure or mole fraction, it is always going to be product raised to power the stoichiometry, reactant divided by reactant raised to power the stoichiometry. If you talk about concentration, it is Kc, pressure it is Kp, and mole fraction it is Kx. Right? Okay. Now here, next is, if you see, units are mole per liter delta Ng, units are atmospheric delta Ng for Kp, and the relation of Kp and Kc is very important, and Kp and Kx is also very, very important. Notes will be provided to you. After this class also, after this session also, you are going to go and visit these notes and write all the formulas by yourself as well. Right now, one thing to remember here is concentration of pure liquid and pure solid is always going to be 1. And you can only get the Kp value if at least one reactant or product is gaseous. Only then that is possible. Okay? Understood? Next is factors on which K depends. So if you reverse that reaction, this K will be inversed. If you multiply, then the factor that you are multiplying it will be in the power. If you divide it, the factor that you are dividing it will be 1 by n. When you add two reactions, their equilibrium constant will be multiplied. When you subtract two reactions, their equilibrium constant will be divided with each other. Okay. Next is this formula, very, very important. Log K2 by K1 is equals to delta H 2.03 R T2 minus T1, T1 into T2. Very, very important formula. For exothermic, T and K are inversely proportional. For endothermic, they are directly proportional to each other. Right? Then if you see the extent of these reactions, if you see for this one, if you talk about it is, it should be less than, see, wait a minute. If it is greater than, if it is less than 10 raised to power minus 3, if it is greater than 10 raised to power 3. Okay? So it is less than 10 raised to power minus 3, it is very slow. It is greater than 10 raised to power 3, it is a very fast reaction. Talking about this QC here, QC has the same formula as QC's reaction quotient. It has the same formula as equilibrium constant. The only difference is that it is not at equilibrium. If QC is greater, it is backward. QC is less, it is a forward reaction. Okay, this also they ask you. Then there is degree of dissociation, that is equals to number of moles dissociated by the initial moles, right? Now, if you talk about the Kc calculations, always remember in Kc calculation, what we use is concentration raised to power stoichiometry. Concentration is there usually in molarity. So that is why here what we will do, it will be number of moles by volume. So volume of the vessel of the flask. So what we will do here, firstly, you will take initial moles as 1. If nothing is given, take initial moles as 1. So 1 minus x multiplied by stoichiometry, x multiplied by stoichiometry, x multiplied by stoichiometry is added in the product side. You take the total, these are the moles. When you divide it with the volume in liter, you will get the concentrations here. Once you know the concentration of A, B and C, directly put this in this formula and you will get the answer for Kc. Now similarly for Kp, you need to have partial pressure. Partial pressure is calculated as mole fraction multiplied by the pressure that will be given, pressure of that vessel, right? So for that, first you calculate the moles the same way that we have calculated. Then calculate the total number of moles. Add all of this. That will be 2 minus 3x. It will be different for different reactions, right? Then you multiply it with the total pressure. You will get the partial pressure. Then put it in the equation of Kp. That is the equation of Kp. That is nothing but Pb cube Pa square Pc square Pc4. That will be different for different reactions. Put all the values, you will get your answer. Next is the relation between delta G and K equilibrium. Very important. Frequently asked question, right? So here R and T value you already know. K equilibrium will be given to you. Delta G they will ask you either directly value or they will ask you whether the reaction is spontaneous or non-spontaneous. If delta G is negative, it is spontaneous. It is positive, it is non-spontaneous. It is 0, then the reaction is at equilibrium. Okay. Then talking about ionic equilibrium here, what you have to remember for ionic equilibrium, very simple. First is Kw, that is your ionic product, that is equals to H positive and OH negative. At different values, at different temperatures, the value of Kw also changes, right? That is why we say that as we increase the temperature, Kw is increasing here, right? And here, because Kw is increasing, so H positive concentration is also increasing and pH is decreasing. OH negative is also increasing, so pOH is decreasing. This formula we have done before also in chemical equilibrium, that is log K2 by K1 delta H 2.03 R T2 minus T1 divided by T1 into T2. It's a very important formula, right? Then this is how do you calculate pH of anything? P of anything is equals to minus log of that anything. So pH is equals to minus log of H positive. pOH is equals to minus log of OH negative. Okay? Now the question that they ask you is based on the calculation of pH for different cases. For strong acids, what you do, H positive ion concentration plus 10 raised to power minus 7. Now 10 raised to power minus 7 will be ignored if H positive ion concentration is greater than 10 raised to power minus 6. Similarly, in case of strong base, you add 10 raised to power minus 7 here to the OH negative concentration, but that will be ignored if your OH negative concentration is greater than 10 raised to power minus 6. If you have two strong acids, then you will have H positive ion concentration is M1V1 plus MN2V2 divided by V1V2. M1 and M2 are the molarity. This N and this M are the N factors. Like HCl will give you 1 H positive. H2SO4 will give you 2 H positive. So these are the N factors. If you have two strong bases, you will calculate the value of OH negative here with the same formula. Here N and M will represent you the N factors of the bases, right? Okay. Next is, if you have one strong acid and one strong base, so you have to subtract the normality and volume. That means you have to use this formula N1V1 minus N2V2, V1 plus V2. Okay. So here, ma'am, can we calculate H positive or we will calculate OH negative? Whatever has greater value. If N and V multiplication, normality and volume multiplication of base is greater, then you are calculating it for base. If N normality and volume multiplication for acid is greater, then you are calculating H positive value. Okay. Next is for weak acid, directly we can say KaC alpha square is the important thing. This is the important formula. Then for weak acid, directly you can say the pH calculation has this formula, very important. Ka value, concentration of that acid will be already given to you. This formula you can skip. Okay? This has never been asked, so you can skip this formula. Next is for buffer. Okay. For buffer, acidic buffer, basic buffer or salt buffer. For acidic buffer, this is the formula, salt by acid. For basic buffer, instead of pK, you have pKb, and instead of acid, you have base here, right? For salt buffer, you have half of pKw plus pK minus pKb. That is going to be the answer here. Range is from pK minus 1 to pK plus 1, pKb minus 1 to pKb plus 1. This you can skip here. This also is not very important for you, right? I am only telling you those formulas that are important. Then salt hydrolysis forms a very important thing. You have anionic, that is when you have weak acid plus a strong base, strong acid plus weak base, weak acid plus weak base. Now, if one of them is weak, then this is the trick that you are going to use. That is KH that is degree of hydrolysis. Hydrolysis constant is Kw by K of the one that is weak. So for weak acid, you will have Ka. For weak base, you will have Kb here. Right? What is H? That is under root Kh by C. You put the value Kh, take it in the under root, divided by C. That will be the answer. Okay? Similarly here, take it in the under root, divided by C. This will be the answer. Okay? That is the value for degree of hydrolysis. That is next is H positive concentration. Beta, either so you can solve this, that H positive is for weak acid, OH negative is for weak base. Okay? For weak acid, H positive concentration is C into H. C into H, this is the formula. This also C into H, this will be the formula that you will get. But ma'am, do I need to remember all of this? In the end, this is the trick that I have told you. In the end, if you can remember, directly remember this formula for pH of weak acid and strong base. This is the formula for pH of strong acid and weak base. Okay? This is for weak acid, this is for weak base. Directly the formulas you should remember. Right? Next is, if both are weak, then this is the trick that I have told you here. If you want to derive things. Okay? Some students are not good in memorizing. So KH is equals to KW by V. Both are weak, so it will be K into KB. H is equals to under root of KH, take the under root. H positive is equals to Ka into hydrolysis. So Ka multiplied by this, you will get this as your answer. Okay? This is for the derivation part. But I would advise you directly remember the pH value here, that is 7 plus half pKa minus pKb. Directly remember the pH value. Okay? That is really going to help you. Now, this question is very, very favorite of NTA. That is, they are asking again and again, solubility product. Okay, so here it is. Direct trick is this stoichiometry raised to power the stoichiometry, this stoichiometry raised to power the stoichiometry, solubility, add these two stoichiometries here, that will be the value of KSP. But if you have common ion effect, okay, if you have common ion effect, you have some common ion here. This is also giving you F negative, this is also giving you F negative. Here you have taken out the answer as 2s because here you had 2f, so answer will be, if this is s, this will be 2s. Here they are saying the concentration of this is 0.1, so this is also going to be 0.1. So here you are going to add 0.1 because this is also fluorine, this is also fluorine. So you are going to add 0.1 here, you are going to add 2s here. So eventually, in place of, when you compare 0.1 with 2s, 0.1 is greater, so that is why approximately it is going to become 0.1 only. Then you can write the answer in the end, that KSP is equals to this stoichiometry, solubility raised to power the stoichiometry, solubility, that is 0.1 raised to power the stoichiometry, that is 0.1 square, and that is how you will get the answer if you have common ion effect. Directly, if you have no common ion effect, directly you can apply this trick. Okay? Next we have is thermodynamics. Okay, next is for thermodynamics. Let us see how you're going to answer this. Thermodynamics formula, students usually get confused here. So I'll tell you some simple way how you can remember. First thing, beta, always remember if irreversible is mentioned, they have mentioned irreversible in the numerical. Maybe sometimes they will not mention irreversible, sometimes they will directly write at constant external pressure. That means irreversible only because you are having a big one step you are choosing here. But in case of reversible, you have variable external pressure. These are two very important statements. Next is, first law of thermodynamics is delta U is equals to Q plus W, where if you talk about work is equals to minus P delta V. Don't confuse it with physics because the formula is different. That is why the sign conventions are also different. If work is done on the system, system is happy, positive. Work is done by the system is very sad, why I am doing the work. If heat is released by the system is very happy. System has to release the heat, is very unhappy. Why I have to give the heat? Negative. If system is absorbing the heat, he is very happy that I am getting the money. Right? So according to the sign conventions, you have these two formulas. Then these are the your basic definitions. Isothermal delta U and delta T is 0. Isobaric delta P is 0. Isochoric delta V is 0. Adiabatic heat change is 0. That is Q is 0. Very important formula. Always if they mention heat energy at constant pressure, that means they are talking about delta H. Heat energy at constant volume, that means they are talking about delta U. That is internal energy. Right? Next is work done formulas, beta. Usually they ask you question based on work done formulas. So work done for isothermal reversible is going to be directly this formula. For isothermal reversible, irreversible means this formula. Reversible means the formula of integration. Reversible you are doing in small step. That is why you have this formula that is derived after integration. Remember here you have log V2 by V1. But if they have given you pressure, then it will be log P1 by P2. Okay. Next is for adiabatic. For adiabatic, beta, this is the formula. Okay. Work done for adiabatic is NCV T2 minus T1. But important thing, ma'am, what is this gamma? What is all of that? I'll tell you that. But before that, we have to do heat capacity. So I'm leaving this page for 2 minutes. I'll come to this page again. Okay. But before that, let us do isobaric. For isobaric, we know that pressure is constant, so work done is equals to minus P external delta V directly. For isochoric, volume is constant, so delta V is constant, so work done will be 0 only. If you talk about open vessel, work is equals to minus delta NGRT. For free expansion, work is 0. Internal energy is also 0. Heat energy is also 0. These are some of the important conclusions that I am telling you, right? And for cyclic process, work done is equals to area enclosed under the curve. For clockwise, it is negative. For anti-clockwise, the work done will be positive, right? Now let us see what is heat capacity. Beta, heat capacity is heat change at 1 degree Celsius. Okay? So this is at constant pressure, Cp is equals to Qp by delta T. Qp is nothing but that is delta H. Remember one thing, the formulas that I am telling you here are very important. Now don't tally this with your NCRT, because in NCRT they have mentioned Cp is for 1 mole. Okay, that is why students usually get confused, because in the paragraph they have given the detailed information. So if you are directly learning the formulas, remember this thing. Cp is equals to delta H by delta T, but here Cp is nothing but for n moles. Cv is equals to delta U by delta T, but Cv is nothing but it is n moles. If you write Cp for n moles and Cv for n moles, then for molar heat capacity, that is for 1 mole, it will be Cpm and Cvm. And the formula is delta H is equals to n Cpm delta T. Delta U is equals to n Cvm into delta T. Okay, these two are very important formulas. Next is, this is specific heat capacity, which is for 1 kilogram of mass. So that is why we divided the heat capacity with m, right? This is not very important. Molar heat capacity is very, very important, right? So gamma is equals to Cp by Cv. Here you can write Cpm by Cvm. Cvm and Cpm is Fr by 2. Cpm is R plus Cvm. Okay? Now, you should remember this thing, that always Cpm minus Cvm is equals to R. Cp minus Cv is equals to N. Because here I am representing this for 1 mole, that is why it is Cpm minus Cvm is equals to R, but Cp minus Cv is equals to N into R. Okay, that is very important to note down. Now, if you see for different things, that is, if you have atomicity, let's say you have monoatomic. For that, degree of freedom is 3, so Cv is equals to 3R by 2. For diatomic and linear polyatomic, degree of freedom is 5, so it is 5R by 2. For non-linear like SO2, it is 6R by 2, that is 3R. Okay, directly from there you can also calculate the value. Here I'll write Cpm, Cpm, Cvm. Okay, Cpm is equals to Cvm plus R, so you will get this as the answer. Then solving it, gamma will be 1.66, gamma will be gamma will be 1.33. Gamma is nothing but it is the Poisson's ratio, that is Cpm divided by Cvm. Okay, I hope so you understood all of that. Now let us come back to this adiabatic formula. So if you see this here, it is work done is equals to n Cvm T delta T. Why it is so? Because beta, if you see now, first law of thermodynamics is delta U is equals to W plus Q. Q is 0. That means work done is equals to delta U. Delta U is nothing but n Cvm delta T. That is why directly we have written it here. Now, for irreversible adiabatic, how you will calculate the value of T2? By using this formula. Everything else will be given to you in the question. But if they have given you reversible adiabatic, then T2 you will calculate by either of this formula. Okay? Sometimes they don't ask you, trust me, they have not asked till now, so they have not, in JEE Mains they don't ask you this much lengthy question. Either they will directly ask you the work done, very rarely. Work done usually they ask for isothermal, reversible and irreversible, right? Here, what are the maximum chances that directly they will give you some value of P1 and P2, V1 and V2, or T1 and T2 or V1 and V2, or P1 and P2 and T1 and T2, and they will ask you the value of gamma, right? or they will give you the value of gamma, they can ask you the value of P2 in the adiabatic, T2 in the adiabatic, V2 in the adiabatic. So for that you have to apply any of this formula depending upon the question. First thing is this question can be. Second thing is either they can only ask you that you have irreversible process, calculate the value of T2, other things will be given to you in the question. Okay? All of this they will not ask you in one question only. These are three different questions that they can ask you. Maximum chances are for this one and this one, not this one. This one though most important, most important. Right? Chal. Now let us do. Here also directly they ask you for monatomic, diatomic, linear polyatomic, what is the gamma value, directly also they ask. Right? Then for enthalpy, beta, we have two major formulas of thermodynamics from where right now they are asking you questions. First is Gibbs-Helmont equation, where this is delta G is equals to delta H minus T delta S. Here, either they ask you spontaneity and non-spontaneity of the process, delta G negative spontaneous, delta G positive non-spontaneous. Sometimes they also ask you the temperature on the spontaneous conditions. So you have to apply delta G is negative, then you have to calculate the temperature for that. Now for this formula that is also called as, here you can write delta H is equals to delta U plus delta PV. If pressure is variable, then you will have delta, V delta P. If volume is variable, then you will have P delta V. Right? According to you will have the answer. Acha. Now see this. If delta H is equals to delta U plus delta NGRT, then simply what you will write here. Either here you can give you QP, in this place they can give you QV, right? Delta NG you will answer it from the chemical reaction. So if chemical reaction is given to you or the name of the chemical reaction, the hint of the chemical reaction is given to you, then you will use this formula. If pressure and volume is given to you, you will use this formula. Got it? Okay. Then this is for entropy. Just remember these two formulas. If you say for reversible adiabatic, Q reversible is 0, so delta S will be 0. For irreversible adiabatic, you will use any of this formula. And here they don't ask you calculative questions. In this, they will directly ask you the formula. Directly formula if they ask. Directly formula will be asked. So remember this thing, for isothermal, any of the formula you will use, erase this and erase this. For isochoric, choric means volume, use this formula where erase this. For isobaric, use this formula and erase this. That's it, because P1 is equals to P2 in isobaric, so this will be 0, right? So according to that, you will have your answers for different processes. Is that clear? Now for thermodynamics, just remember one thing. If hint is given for bond energy, it means they have asked you the delta H of reaction, but bond energy is given, then it will be reactant minus product. If anything else is given to you, then that will be product minus reactant. Okay, is that clear? Chal. Now, next is you have solution chapter here. Solution chapter, let us answer that. So first is Henry's law. Directly Henry's law is what is P is equals to KH into, this is Henry's constant into mole fraction. Directly use this formula, right? These are the applications. You can go and check that out because these are not included in the formula. So I am just giving you the notes. You can do that yourself as well, right? Acha. Next is Raoult's law. For Raoult's law, this is the formula that PT is equals to partial vapor pressure of all the components. If you write the formula of partial vapor pressure is equals to pure vapor pressure multiplied by the mole fraction, right? So you can simply solve this, write it, and these are the two formulas that you will get in the end. Now for ideal solution, delta H mixing delta V will always be 0, but delta S will always be greater than 0, delta G will always be less than 0, any of the processes, right? Next is colligative properties formula. So we have 4 colligative properties here. So first is relative lowering in vapor pressure. This is the formula that is directly proportional to the mole fraction, right? Delta TF is equals to Kf into molality, that is a formula for depression in freezing point. This is the formula of elevation in boiling point. And this is the formula, this represents osmotic pressure. Okay, molarity, I have already told you in the starting, right? Now, what is van 't Hoff factor? That is number of particles after association divided by number of particles before. Directly van 't Hoff factor you will put for a non-electrolyte, that will be 1. But for the electrolytes, you should use this formula for dissociation and this formula for association. Degree of dissociation and association will be given to you in the question only. Next is for conductance, use these formulas. One is this R is equals to rho L by A. Then you have a very, very important formula, that is G into G star is equals to kappa, where G is the conductance, G is the conductance, G star is the cell constant, and K is the conductivity, right? And next question what they can ask you is delta M at concentration C is equals to kappa into 1000 by molarity. Equivalent conductivity is kappa into 1000 by normality, right? And if they ask you the degree of dissociation, this will be molar conductivity at concentration C divided by molar conductivity at infinite dilution. But to remember that at infinite dilution, the molar conductivity will be solved by Coriolis law. Okay? Once you have molar conductivity, directly solve it. That is Kc is equals to C alpha square. That is for weak electrolyte, that we have done in ionic equilibrium as well. Faraday first law, W is equals to ZIT. Z is nothing but E by F. E is what you can directly remember. W is equals to molar mass into current into time divided by N factor into Faraday's, right? Second law is that you have weight of metal divided by weight of metal B. That means you can say the weight of one thing divided by the equivalent weight will be equal to the other if you have two things in parallel, in series. Okay? Okay. Then we have chemical kinetics. From chemical kinetics, some of the formulas are, first thing is you should remember that rate of reaction, if you are directly solving, you have to divide it by the number of moles, right? If it is disappearing, you will have negative. If it is appearing, that will have positive. If you are directly calculating rate of appearance and disappearance, then you don't have to divide it with the number of moles. That is the first point. Second is that first thing, so you have this formula. Wait a minute. This formula, that is for directly the units of rate constant if any order is given to you. This is the dependence of T half on initial concentration if any order is given to you, right? Very important formulas. Then you have the equation of Arrhenius equation, that is E is equals to, this is Arrhenius constant, E activation energy by RT. From this we also got this equation from where numerical based question is asked, right? Next is zero order, first order and second order reactions. As you can see, zero order, first order, and this is second order. Mostly first order reaction will be asked to you. This formula is extremely important. R0 is initial, RT is the final concentration, T half is the time period when 50% of the concentration is consumed. Okay, you can go through these formulas. These are very, very important. Now, last is our formulas for electrochemistry, right? So that is delta G is equals to minus NF E0 cell, right? Then delta G dependence on Kc, then E0 cell and Kc dependence, right? This all has been generated from this equation, that is the Nernst equation, that is E cell is equals to E0, 0.059 divided by N is the N factor. This is the E0 cell that you can calculate by E0 cathode reduction potential, my E0 anode reduction potential. Okay. Now, next is very, very important. Now, very high chances they will ask you from this conversion of energy. See, delta G is conserved, but electrode potential is not conserved. That is why if you have A to A positive to A, then you can directly say that delta G of this third process is equals to delta G of 1 plus delta G of 2. Putting this formula here, you will get N3 E03 is equals to N1 E01 plus N2 E02 directly. And this beta, I think for the third time I am repeating in this video, right? Which is spontaneous, which is non-spontaneous, right? Then you have the last one. This also I think we have done before also. Okay, this also beta, I have told you this also. Just now only we did, na? Just now only we did the value of this R, rho, L, A, है ना? This molar conductivity, equivalent conductivity. This also we have done. Just now also we did. Just now only we did, right? So last one, Corlosh law, beta. This also I told you. Corlosh law basically states that infinite dilution molar conductivity. See, this is the graph. What we saw that for weak electrolyte, we are not able to find any intercept. That is why this statement says that this formula is also important. Here they will just ask you the formula, nothing else. Formula for strong electrolytes, that's it. Right? So Corlosh law for infinite is equals to the stoichiometry multiplied by the infinite dilution molar conductivity at of each ion. Right? Okay. Next we have, so size is directly proportional to molar conductivity at infinite dilution. That is why more the size, more is the molar conductivity. Right? From there, this we have done in ionic equilibrium as well. This is C, this is 0, 0, C minus C alpha, C alpha, C alpha. So Ka will turn out to be C alpha square. So alpha is equals to molar conductivity at concentration C divided by molar conductivity at infinite dilution. Okay. So that was all about all the formulas of physical chemistry, right? So I tried my best to revise them all within very less time, right? Now students, if you have, all the things are getting revised in your head, then I would love to know your comments in the comment section, what you feel about this. I know I was a little fast here. Why I was fast? Because this is a revision session. Okay? This is not an explanation session. Okay? So this is all the revision points, all the formulas I have concluded here. Now what you need to do, right? Comment down below if this was worth it or not. And also I'll provide you with the PDF here. The PDF will be there in the description box only. You will see if this is the video when this will be uploaded, just like the same I did for organic chemistry also, right? So like here you can see session PDF. Similarly, here also in this physical chemistry formulas also you will see the session PDF. And other things are, you have last mile series, test series for you, which is very beneficial for you at this point of time. That is available to you, right? As you can see here, right? Then there is extra mile engineering test series for 2025, where we are providing you test series for 10 top engineering exams. So you can see that that is also available to you in the description box only. After this, without any, if you see ma'am, without notes, with just one revision, ma'am, will we be able to do this in the exam? Beta, no, you have to write down the formulas yourself. Only then thing will be very smooth for you, right? So I'll see you all in the next video, next session. But I would love to know your comments in the comment section, and do hit the like button here, because so much energy I have put into this video. This 1 hour video has actually taken me around 5 to 6 hours of hard work, right? As you can see for yourself. Okay, then this is Diksha Kaushal signing off. Bye bye. Take care.